MR Credit 6, Rapidly Renewable Materials. New construction, 1 point available. Schools, 1 point. It's not available for core and shell. The requirement is to use rapidly renewable building materials and products for 2.5% of the total value of the building materials and products used in the project. It needs to be made from plants that are typically harvested within a 10-year cycle or shorter. These products are usually made from plants that are more dense and need less maintenance and less land for agriculture. And similar to the other credits, it's based on cost. And you can get an innovation design point available for just 5% of the total material budget being from rapidly renewable materials. I see a lot of projects avoid this because they think bamboo is the only solution, but there's actually a wide range of materials that comply with rapidly renewable material criteria, even though bamboo is a good example. Other materials to consider include wool insulation and carpeting, cotton bat insulation, sunflower seed board panels, agrofiber board, linoleum, which was surprising to me, but linseed oil is actually rapidly renewable, wheat board chemistry, and cork flooring. Cork flooring can also help with acoustics as well. On the right, you see some examples of this. You see someone installing rigid board wool insulation. So it can come in different forms. It's important to check GreenSpec, buildinggreen.com, and other resources to shop for alternatives to traditional building components. Performance is always most important, but there are materials that are actually competing with your traditional building components and still have these sustainable attributes. First, you need to determine the total material cost. You can either use the default 45% material value we discussed previously, or better, the actual material cost according to the CSI format schedule of values. You need to create a table with the product name, total product costs, the percentage of product by weight that meets the rapidly renewable criteria, the material manufacturer, and you need to keep all the manufacturer's data sheets documenting the rapidly renewable origins. For the calculation, it's the total cost of rapidly renewable materials divided by the total material cost times 100. So for assembly, where only part of the product is rapidly renewable, you take the rapidly renewable weight divided by the total weight of the product, and that percentage you multiply towards the cost, and that's the total cost of rapidly renewable material. That's what you plug in and then divide by the total material cost. That's for assemblies where only part of the product is rapidly renewable. And that's similar to recycled content, regional material, and rapidly renewable materials. So make sure you understand that calculation method. Bamboo is not the only rapidly renewable product, but it is a great example. Here's some fun facts about bamboo. It's a grass and the fastest growing wood-like substance on the planet. Moso bamboo, it's the variety most commonly used in flooring and building products. It grows to a height of 50 to 60 feet in only 18 months. So as a toddler, it's 60 feet tall. It also reaches maturity and can be harvested after 4 to 6 years of growth rather than 30 to 60 years for trees of most types. And the day after a stalk is harvested, there will be 4 to 7 plants in its place, therefore the rapidly renewable. It can also offer incredible erosion control due to its rapid generation. Now you have to be careful about this because it can also take a rampage on native species if it's not maintained or used in a corrective way. So just keep in mind that there's always trade-offs to these strategies. You make sure to use bamboo in a responsible way, especially for something like erosion control. But as a building product, it has great tensile strength. As you can see here, it's used for fencing in a terrace-like structure. The last credit in the material and resource category has to do with wood. Here's a fun fact: the first use of sustainability I have found. In 1713, Hans Karl von Clausewitz used the phrase, I don't speak German, but there it is, which describes the forestry practice that limit wood cutting to the forest's average annual growth. And basically that's sustainability in a nutshell, only using as much as can be replenished by nature. It can rejuvenate itself if we give it a chance, so it's just about being smart with our resources. And many historians consider this to be the first use of sustainability in its modern meaning. And it's a very, very simple concept. My grandma was my mentor in sustainability, and that's really because she survived a depression and found out she has to be self-sustaining, reuse things as much as possible. And I think we have to have that same type of mentality, even in high times, because we have to prepare for depleting resources and in times when there isn't so much flourishing around us. MR Credit 7, Certified Wood. The requirement is to use a minimum of 50% of wood-based materials or products that are FSC certified. That standard you need to know is the Forest Stewardship Council. This is important to note. Components could include framing, flooring, and subflooring, wood doors and finishes. And there is an innovation design credit available if 95% of the wood budget is FSC certified. In pre-bid, it's important to provide project bidders with a list of certified vendors and encourage them to make contact early in the project to establish product availability and pricing. To ensure availability, consider owner purchase or pre-purchase even, store and supply particular items to the contractor. FOIC, furnished by the owner, installed by the contractor. And this can just ensure that those items will be accessible to you when you need them, because it is a stringent certification process. So it's important to make sure that you have items that are accessible to your site that have gone through the proper verification process. And if they have, they will have the proper chain of custody documentation right on the product. The chain of custody requirements include collect a vendor invoice for all permanently installed wood products, identify each product on a line item basis, identify each FSC certified product on a line item basis, and show the dollar value of each line item, include the vendor's chain of custody certificate number. This is important to verify for quality assurance on site that when wood comes on site, it has that chain of custody number right on it. And that an FSC accredited certifier must certify each vendor as well. So even where you're purchasing that wood, if the wood even comes off the truck and goes into a lot that wasn't certified to handle that FSC product, it loses its chain of custody. So it's important to be diligent in this process. Documentation is key. You need to track all purchases of FSC certified wood products. Keep COC documentation for each purchase. Keep invoices for all certified wood purchases. And keep a list stating the percentage of certified wood in each purchase. So it's a full verification process from the forest to the vendors to the site. There's actually a forest management certification that's awarded to responsible forest managers after their operations successfully complete audits of forestry practices and plans, which means you're ensuring that Hans's definition of sustainability is meant, that the forest can replenish itself in a healthy way. The chain of custody certification is awarded to companies that process, manufacture, and or sell products made of certified wood after audits verify proper accounting of material flows and proper use of the FSC name and logo. It's not something that can just be assumed. The FSC name and logo is earned, and that chain of custody is a critical verification component to check on site and in your lead documentation. So equation 1, take the certified wood which equals Forest Stewardship Council certified wood value over the total new wood material value. So for assemblies, only percentage of FSC certified wood can be applied. There's FSC pure and FSC mix, which equal 100% FSC. You need to determine percentage of new wood in FSC wood based on weight, volume, or cost. Cost would be most beneficial in the case of veneers, where you have lighter weight but more cost. And then you enter these values in addition to the total value of the product into the submittal templates. Once again, it's important to track this as materials come on site. The environmental benefits of Forest Stewardship Council include long-term health and productivity of forests for timber production, wildlife habitat and productivity of forests, clean air and water supplies that we depend on, and climate stabilization. So once again, trying to reduce climate change. Our built environment is a big contributor to how we use our resources that affect our environment. Social benefits, so once again looking at that triple bottom line of economics, environment, and social benefits. There's long-lasting community employment derived from stable forest operations. So instead of just clear-cutting and moving on, this is actually something that can help a local economy. General overview. The value of recycled wood fiber content of a product that qualifies for MR Credit 4 recycled content materials cannot be applied to MR Credit 7 certified wood. Materials qualifying for MR Credit 3 material reuse cannot be applied to MR Credits 1, 2, 4, 6, or 7, but they can be applied to MR Credit 5. This is important to understand for the test when they apply these questions to different case studies. Exemplary performance for material and resource section include MR Credit 1, build and reuse. You want to maintain existing walls, floors, and roof. It's only for core and shell. So if you maintain 95% of the existing components, you can get exemplary performance point. For MR Credit 2, construction waste management, 95% of the materials and waste is diverted from the landfill. You can earn this exemplary performance point. MR Credit 3, material reuse. For new construction schools, it's reuse 50% materials out of the total material budget, or 10% for core and shell. Recycled content is 30% recycled content based on that post-consumer recycled content plus 1/2 pre-consumer recycled content. Regional materials is 30%, both manufactured and harvested raw material within that 500-mile radius. For rapidly renewable, it's 5% rapidly renewable material. MR Credit 7, certified wood, it's 95% FSC certified wood, and that's of your total wood budget, just for that credit. It's a case study of Miro Tea in Seattle. If you're in the Northwest, the Eco House is an eco-friendly material selection. There's places all over the country, vendors helping you select green products and get started. Once again, beware of greenwashing. Make sure to ask good questions. But even a Home Depot can help you start to make these decisions. It's important to be a smart purchaser. For this example, eco-friendly materials included YOLO Color House Paint, which is a local Portland paint company that really started their company with the premise of seeing how sustainable paints and coatings could be. It's a premium water-based paint, 100% acrylic, and Green Seal certified, which pertains to low-emitting materials in the indoor environmental quality section coming up next. Squawk Mountain Stone was used on the countertop. It's a soapstone-like composite made from recycled waste paper, glass dust, and low-carbon cement. Kiri board is the wall board you see. Its Japanese name means clean and beautiful. It's made from the stalks of the sorghum plant, which is harvested within a 10-year cycle, meaning it's rapidly renewable, according to the LEED criteria. The stalks are a reclaimed agricultural fiber because they are usually burned or thrown into landfills after harvest. So in addition to being rapidly renewable, it's using something that would have been otherwise burned. Now, if you are in the U.S. and speccing this carrier board, you have to take into consideration the carbon footprint of shipping it from Japan. But everything in sustainability is a cost-benefit analysis. Nothing is perfect. Menu of choices to build a perfect green building. So it's important to understand the process, ask the right questions, and continuously do this cost-benefit analysis, and then track your totals throughout the process and keep good communication with the team. And we'll look at how to utilize tools in real-world examples in some of our exercises. One case study is Les Schwab in Oregon. It took advantage of local incentive program called Energy Trust. They received $71,000 in incentives for energy efficiency upgrades, about $43,000 for their solar electric system, and they saw $34,000 approximately in annual savings from energy. So total life cycle cost savings help pay for that upgrade. So here's a case study using the house I grew up on the Willamette River that actually my father, Buzz Gorder, designed back in the early 80s before green was chic. And he actually grew up in Crookston, Minnesota. So when he saw the silos in the Midwest, he pictured them on their side and said, why not make domes out of those? Water doesn't penetrate them. They work great, and it's a good example of salvage material. Corrugated aluminum is durable. It's never been painted or washed, so there's no chemicals going into the river, and you save on those materials. And here are some other characteristics. See if you can correlate it to some of the credits we've talked about today. So the siding, recycled aluminum. Maybe MR credit 4 came to mind, I hope. Deck, wood with FSC approved chain of custody. MR credit 7. Cabinets from sunflower seeds. This can be a trickier one. Remember that long list of rapidly renewable. Bamboo flooring as well. Mineral wool insulation, both rapidly renewable. And a table made from an old door, reused material. Once again, it's just looking at our materials in a new way with a new lens. Into the material and resource section.